Hello, ladies and gentlemen. Today we're going to be taking a look at something new called logarithms. And for this, you're going to need a calculator as well as your notes. This is a new type of notation, one you have never seen before, that is used to help us solve for x in certain situations. So we're going to need this skill later on when we go about solving for x. This idea of what is a logarithm, what does it represent, is a really big one for us. So here's where your notes begin. Make sure that you get this chart in your notes. We're going to take a look at something that's familiar to you, and that's exponential form, and then build this idea of what is logarithm form, or what is a log. So a base, an exponent, and a value it equals is something we're familiar with, and then we're going to convert it into this new notation called logs. Here are a few examples you would want to get in that chart. There are true facts here. 2 to the 4th power is 16, 10 to the 1st is 10, and 3 to the 0 is 1. Now, in these expressions here, guys, 2 is considered the base, and 4, remember, is the exponent. And then 16 would be the value that it equals, and so on for the rest here. 10 is the base, 1 is the exponent, the value it equals is 10. 3 is the base, 0 is the exponent, the value it equals is 1. So all of these things have key features. Now what's unique about log form is it's going to be a way for us to isolate the exponent, to get the exponent alone on the other side. Why would we want to do that? You're going to see more about why that happens, or why we would want that in days to come. Here's the idea of log form, though. Log form starts with the word log, of course, so that people know what form it's in, and then logs also have a base. So we steal the base here that was the 2, we take him and we make him be a log base 2. Now the base doesn't just go right next to him, he's kind of sunk down a subscript. Then the 16 value comes next, okay? And then the equal sign, and then the 4 is the exponent, okay? The exponent travels and he becomes on the other side of the equation there. So the exponent is alone. So the base is here now. 16 is the value that it equaled, and 4 is the exponent. Notice that the exponent alone is alone. So a logarithm will equal an exponent. Okay, a logarithm will equal that exponent on the other side. How would we rewrite these things on the other ones here? Well, let's take a look. We'd start with the word log. What base would we use? The base was 10, so we're going to keep the base. After that comes the value. So it'd be big 10 here, okay, not a subscript, but a regular 10 here, equal sign, and then on the other side there is the exponent, so that's the 1. Continuing on, log, what's the base? 3. After that, the value it equals 1. What's the exponent? 0. So we're just kind of moving things around and rewriting in this notation so that the exponent can be by himself or isolated. So let's continue to practice some more of these. Please get this part in your notes. A logarithm will equal or isolate that exponent. That's what we were just saying. That's what it's good for. So let's look at the base and the value here and try to figure out what is the log, or what's the exponent that we're looking for. So if I was going to read this, this says log base 3 of 9. So what is that really asking me? This is saying what exponent on 3 makes 9. So 3 to what power makes 9? 2. 3 to the 2nd power makes 9. Okay, let's continue on with the next one. What about this one? What exponent on 4 gives me a value of 16? 2. 4 to the 2nd power makes 16. This one's a little trickier now. What power on 4, so 4 to what power makes 2? The answer, 1/2. 4 to the 1/2 power makes 2, because a 1/2 power is the same thing as a square root, ladies and gentlemen. Okay, good idea there. And the next one is what power on 3 makes -1? So 3 to what power equals a -1? 3 to the 0 makes a +1. 3 to the 0 is +1. You might be thinking something negative. 3 to the -1, though, that's 1/3 because the negative exponent moves it to the bottom. -2 would just be 1/9. It's not looking like you can ever multiply a bunch of 3's. and turn it into a negative number. So this one has no answer, no solution. Okay, cannot be done. That idea that sometimes our answers or our values cannot actually be figured out here because we're talking about finding exponents. So here's the deal about your calculators. You may not always know the answers to those questions in your head. Like maybe you got a log base 3 of 8. What power on 3 makes 8? 3 to what power gives me 8? I don't know. 3 squared is 9, but that doesn't make 8. So there are some times when you're going to need a calculator to help you figure these out. If you don't know what we're doing or what those exponents are, then you need to have a calculator in order to help you. So the deal with calculators is this, though. Unfortunately, most standard calculators are only programmed to calculate logs with a base of 10. So because of that, your calculator may not just have a way for you to just type it all in. So we have a change of base formula. So write this in your notes using your calculator. Okay, using your calculator. We're going to use something called the change of base formula to make this happen. So I'd add that little phrase up there. To calculate a log on a calculator, use the change of base formula. Here's what the change of base formula looks like. It looks scary, but it's really not that difficult, okay? It says take any log. This is your original problem, okay? This is the original. And over here is what I type in my calculator. Okay, what I need to do to get it in my calculator, or get the actual answer from my calculator. So this takes any log, no matter how it's written, and makes it calculator friendly, so that your calculator, no matter what kind you have, can do it. Okay, every scientific calculator will have a log button on it. And like I said, sometimes most of these calculators cannot do any other type of log other than base 10. So if that's the type of calculator you have, you need to know how to get these values as well. So log base 10 of the B, log base 10 of the A. Notice that here, this is a divide sign. So this is what the change of base formula says. Take any log you have. Here's the little base guy, right? And here's the value part. Okay, notice we take the log of this first, and we divide it by the log of that. Okay, log of the B gets divided by the log of the A, and where those are in that location. So let's practice a few and try to get these values from my calculator. Okay, write these in your notes. You're going to want to write the what I type in my calculator, and then the actual answer that the calculator gives us. And then we'll kind of finish up there on the side with what does this mean to kind of reinforce what a log actually represents. I'm going to try to move my little cursor here. So here we go. Log base 3 of 81. What do I type in my calculator? Here's what you would type in your calculator. According to the change of base formula, we would type the word log, and we would do the 81 first. So we do log of this divided by log of the 3. So I go to my calculator and I use the log button, and I type in log of 81. Be careful to shut parentheses if you need to. Divided by log of 3. And you get an answer of 4. What does this mean? What is the calculator telling us? Remember, he's telling us what power on 3 makes 81. So 3 to the 4th power makes 81. Let's continue on. What do I type in my calculator on this next one? I do log of 10 divided by log of 2. Okay, so I'll type in log of 10 divided by log of 2. Please remember to close those parentheses if your calculator has them. Is 3.32 approximately. That means that 2 to the 3.32 power is going to be approximately 10. Okay, approximately. Not exact because we rounded that a little bit. So let's continue on the next one. What do we have here? Log base 10 of 1. So this means I would type in log 1 divided by log 10. And I'd go into my calculator and you type that in. Some of you may have noticed. Do I really have to do the change of base formula here? Not really, right? Because that is a log base 10 and your calculator can do that. Okay, your calculator totally understands log base 10. But anyway, you know that that should be a 0. That means 10 to the 0 power makes 1. So continuing again, log of the 2 divided by log of the 64. And we'll ask our calculator log of 2 divided by log of 64. That is 0.16667, which is, as a fraction, if your calculator gave it to you as a fraction, 1/6. Okay, that's the power that equals here. So that means 64 to the 1/6 power, 6th root of 64, equals 2. And then that one that I said, well, one I can't think of, what power on 3 makes 8? Well, let's ask the calculator. Log of 8 divided by log of 3. We'll ask the calculator, log of 8 divided by log of 3. It's not going to be pretty. It's 1.89. That means 3 to the 1.89 power is approximately 8. Okay? So this idea of using logs here to help us find exponents, help us isolate exponents, is going to be a big one that we continue to build on. Thank you for taking good notes today.